Today we speak about games with a negative number of players. I was gonna make an equally hilarious paper about games with just one player, and then I was gonna make the same joke about you playing with yourself about, 100 times. But games with one players are real. They're just like you make a decision. And I talk about it down here. A decision problem, one agent maximizes utility. It's technically, it's not how at least I see games, which is two or more players, but I took it one step further. I'm saying, what happens when you have a negative number of players? Traditional game theory classifies games by the number of players involved / ranging from single agent decision problems to multiplayer strategic environments. This paper extends the typology to consider games with a negative number of players. While no empirical example of such games is known to exist, we offer a formal framework for their analysis, propose possible axiomatic foundations, and explore the implications for theoretical models of decision making. Reverse causality, and anti-agent environments. This analysis opens a surreal yet internally consistent domain of abstract game theory. It's not internally consistent either. I guess what I was thinking of doing for these kind of like funny paper videos is also explain where it's obviously wrong. Because I don't want anyone to be taking me seriously when I talk about games with a negative number of players. But I'm not going to be doing it for this one because I feel like going through that for this one is just a little bit silly in itself. But I'll speak about my argument. So here we have sort of the basics for player typologies. We have n equals 0, so a system evolves without agents. We have n is equal to 1, so this is just a decision problem where you're just one agent that maximizes your own utility. You have n equals 2, so this is where you get your prisoner's dilemma, so these are just strategic interaction. And then you have n greater than 2, so multi-agent systems. You can have now, n goes all the way to n, which is essentially infinite agents, okay? So we ask, what if it's less than 0? What if n is less than 0? And essentially, we just get goofy, okay? We get goofy again. I'll read some of the words. I'm not going to go through some of these are kind of funny. Okay, so anti-participation axiom, each anti-player undoes one player's agency. Reversal principle, the game's dynamics evolve backward through a utility gradient of imaginary slope. And then entropic inversion, the entropy of strategy sets decreases as n goes to negative infinity. Kind of, I think that's pretty good. We're on the complex plane, so, you have I define I as the square root of -1, because everybody does that. Every single textbook that talks about complex or imaginary stuff, they always have to define I before getting into something so complex that you can never even start to, but of course they have to start by telling you that I is equal to the square root of -1, because they do that every single time. God bless their souls, man. And then the rest of the book is just an exercise to the reader. But anyway, applications in theoretical metaphysics, retrocausal inference models, simulating how outcomes influence decision retroactively, quantum entanglement analogies, interpreting strategy as entangled across non-participants, and then game theoretic nihilism, modeling systematic collapse or total indecision, philosophy of agency, defining the lower bound of rational choice as anti-choice, limitations and open questions. Can a game with fewer than 0 players produce observable outcomes? Is there an ordinal extension of Nash equilibrium into the complex plane? And what are the ethical implications of modeling decision-making in the absence of deciders? Conclusion. Though initially absurd, the notion of games with a negative number of players invites reflection on the foundational assumptions of game theory. By extending our definitions beyond the positive integers, we engage with the metaphysics of interaction, the topology of non-agency, and the pure mathematics of vacated choice. And obviously, I think less than no one. Thank you for watching, and I will catch you in the next video.